In this video, we're going to practice finding limits numerically. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now, when we are introduced to limits, we usually approach them in three different ways, and numerically is often the first one we find. Now, the idea of limits is that we're looking at a function, and that's this part right here. This is the function we're investigating. And what we're asking is, what are the values of this function as we get close to a certain x value? In this case, the x value is 2. Now, it's very important to note that we're not asking what is the value at 2. That is irrelevant to us, because oftentimes it's undefined. And if you plug in 2 in for x here, you get an undefined answer, so you can't find it anyway. But what we're looking at isn't what is the value at 2, but what is the value as we get close to 2. Now, the way we find limits numerically is rather quite easy, because all we're going to do is we're going to plug in values that get closer and closer to 2, and we're just going to observe what happens as they get closer and closer. So, to make this easy on ourselves, pull out our calculator, and so the first number we'll start with is 1.5. Now, our function is 8 minus x cubed. So we substitute 1.5 in for x, and 1.5 squared minus 4. And so we get negative 2.64. So I'll put negative 2.64 in this spot right here. So now we want to find 1.9. Now we can try this approach, but I want to show you a faster way to do this. If you have a Texas Instruments calculator, you can make this faster by saying, all right, I'm going to use x as my stand-in variable. And I'm going to press 1.9, and then I'm going to press the store button, which is down here, STO, and then hit store x. Now, anytime I press x, it's going to substitute 1.9 in its place. So now I'm going to type 8 minus x cubed divided by x squared minus 4. Now, it gives me this number because it plugged in 1.9 instead of x. So I put negative 2.92 right here. So now I'm going to type in 1.99 and store that for x. Now, I'm not going to type this expression again because it's already been entered. I'm just going to recall it. How do I do that? I press second enter. Now, what it does is it recalls the previous command. Well, I don't want that one. I want the one before it. So I press second enter one more time. And so here it is. But now, when I press enter, it's not going to give me the answer it did above, because up here, I had 1.9 stored in for x. Here, it's going to be 1.99. And so here we have negative 2.99. So now we can very quickly see that, well, here we're approaching negative 3. Now the question is, do we approach negative 3 coming in from the other side, from the positive side? So we substitute 2.5 in for x, and we plug that in, and we get negative 3.38. And then we substitute 2.1 in for x, and we get negative 3.08. And then negative 2.01, we store that for x, and we recall, and we have negative 3.008. So we are approaching negative 3 from both sides. So for this problem, the limit as x approaches 2 of 8 minus x cubed over x squared minus 4 equals negative 3. So let's look at the next one. Now the next one, here we're finding the limit of this function as t, we're now using t instead of x, as it approaches 0. Now this negative means that it's approaching from the negative side. So if we look back at the first problem, here we approached positive 2 from one side and from the other side. This is the negative side. This is the positive side. Now, anytime we see a negative or a positive, that means we're only looking at one side or the other. So here, since we're looking at approaching 0 from the negative side, we're only going to consider this half. So here, we're just approaching 0 from the negative side. That's what that means. So 0's sitting over here. Now for this problem, we're going to do this one slightly differently than we did up above to see if we can do this a little bit more efficiently. The first problem, a little bit easier than just plugging them in one at a time, but there's a slightly faster way. So go into your y equals. Make sure you're in function mode so that it shows y1 and y2 and so on. And we're going to type in this function. So parentheses for my numerator, 2 minus square root. Now, when you're in function mode, it always uses x. It doesn't matter what variable you're using, but the calculator will still work just fine, even if it's not the variable that we started with. So you have x squared plus 3. Close off the radical, close off the numerator. Then we divide by, parentheses for the denominator, x in place of t plus 1. So there is our function. What we're going to do is we're going to have the calculator set up a little table for us. So to do that, we're going to press second window. That's going to be our table setup. Now, go down to independent and go over to ask. Set that. What that means is we are going to punch in the values of the independent variable, which is what we're doing here in this table. We have these values for our independent variable, and we're going to do that for our calculator. We're going to punch them in, and the calculator is going to give it to us. So we press second, graph. Now we have a blank table, so now we just start filling it in. Negative 0.1, there's our value. Negative 10 to the negative third, there we go. The next one, negative 10 to the sixth, to the negative sixth, there we go. And then negative 10 to the negative 9. Now, one thing you'll often notice that happens with limits is as you get closer and closer, the decimals get closer and closer, and they actually end up not changing very much, because what you're doing is you're getting closer and closer to what it actually is. And in this case, between 10 to the negative 10 to the negative sixth and negative 10 to the negative ninth, the first 5 decimal places actually don't change. Now, this one is not a common fraction, and that's okay. You're going to have some limit problems where it's not going to be a known decimal. So we'll just write this in as 0.29, 0.27, 0.27, 0.27. If your teacher asks for more decimals, that's fine. The calculator will give you more. All right, so let's look at the next one. Now the next one, this one uses theta. Now based on the last example, it doesn't matter what letter we use, or even if it's a Greek letter. This problem will still work the same way. The thing to keep in mind is that since we're dealing with limits, and limits is very much a calculus idea, anytime you see sine, cosine, or tangent, remember that we want to be in radians. So I need to, on my calculator, I need to quit out of that, and I need to go to mode, and I need to make sure that my calculator is in radian mode. If it's in degree mode, it's going to give me a different answer. So now let's go ahead, change out our function from what it was in number 2 to this function in number 3. So we have sine of 6x, close parentheses, divided by x. Now if I return to my table, pressing second graph, I can delete these, delete, 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 delete. And so I can just type in all of these numbers and have a table made for me on this calculator. So negative 0.5, negative 0.1, negative 0.01, 0.01, 0.1, 0.5. All right. So for negative 0.5, it's 0.28. For negative 0.1, it's 5.65. Negative 0.01 is 5.99. For 0.01, it's 5.99. For 0.1, it's 5.65. This seems to be symmetrical. And then we have 0.28. So here we're approaching 0 from the negative side, and we're approaching 0 from the positive side. And in both cases, the limit appears to be 6 as we get closer and closer. So the limit as theta, because that's our original variable, approaches 0, and our function is sine of 6 theta over theta. That limit equals 6. All right. So looking down at number 4, this one is a little bit tricky at face value because we're asking what happens as x goes to infinity. Well, there is no infinity button on certain calculators, and so many calculators can't do this directly. But infinity itself really isn't a number. What we're asking for is, since infinity can't be reached, what happens as you just get bigger and bigger and bigger? So what we have is we have some very large numbers, 10 to the 3rd, 10 to the 6th, 10 to the 9th, 10 to the 12th. And some people prefer to have their exponents jump by larger gaps than 3. I just choose 3 because it's 1,000, a million, a billion, a trillion. If you want your exponents to go bigger, that's fine. That's up to you. So let's type in our new function into our calculator, parentheses for the numerator, 4x plus 3, close off the numerator, divided by, parentheses for the denominator, 5 minus 3x. And now I go back to my table, and I delete all the old ones. One other thing to keep in mind is that a lot of people have a wrong idea about limits approaching infinity, because when most people do limits numerically, they see that a limit has to approach a number from 2 directions. You can't do that with infinity. Infinity just keeps growing. And so this is what we call a one-sided limit. Just like number 2, problem number 2, that was also a one-sided limit, because the numbers weren't converging on something, they were just going off in one direction. Here they're just going off to infinity. So now, on my calculator, we'll type in these numbers. So we have 10. Nope. Let's try that again. We have 10, 10 to the 3rd, 10 to the 6th, 10 to the 9th, 10 to the 12th. And so we have negative 1.72, negative 1.337, negative 1.333, negative 1.333, and negative 1.333. Now these are all approaching the same decimal, and if you recognize this, this is negative 4/3. And so that is what our limit equals. Our limit as x approaches infinity of 4x plus 3 over 5 minus 3x. Now if you've covered asymptotes in pre-calculus before, there's a very easy way to identify what this limit is. If you look at the top and the bottom, you'll see that they're both degree 1. So all you have to do is look at the leading coefficient. On the top it's 4, and on the bottom it's negative 3. And you divide them, and you get negative 4/3. All right. Now at this point, the worksheet's been divided so that now the top row is blank. So if you want a chance to practice, now would be a good time to pause the video and then come back, and then we'll see how you do. All right, so let's try number 5. Now here we're approaching -2. Now, we're not approaching -2 from the positive side or the negative side. So -2 should be right here. And we're going to approach it from the negative side, and we're going to approach it from the positive side. So we need a number that's slightly bigger than -2 and a number that's slightly smaller than -2. So a number that's just bigger than -2 is -1.99. And a number that's slightly less is -2.01. And now we need a number that's just a little bit bigger than that. So -1.9, and note back this way, -2.1. And as we keep going this way, -1.5, -2.5. Now keep in mind, these are not the only numbers you could use. You could have picked -1.99, -1.98, -1.97. Some people prefer to have equal increments. My preference is to just get closer and have smaller increments. That doesn't make me right, doesn't make you wrong. But the key thing is that we want to be getting closer and closer to -2, both from the positive and from the negative side. All right, so now we'll plug in our function, x squared minus 5x plus 6, and then we divide by x squared minus 9. Go to our table, delete out the old values, -2.5, -2.1, -2.01, -1.99, -1.9, -1.5. All right, so the values that I came up with were -9, -4.556, -4.051, -3.95, -3.545, -2.333. All right. So, as we approach -2 from both sides, this thing seems to be getting closer and closer to -4. That appears to be our limit. So the limit as x approaches -2 of x squared minus 5x plus 6 all over x squared minus 9 is equal to 4. Now looking at number 6, we have h instead of x, but that's okay. We're approaching 0. Now we're not approaching it from the positive or the negative, we're approaching from both sides. So 0's in the middle of our table. We're going to approach it from the negative and from the positive side. So we have 0.01, 0.1, 0.5, -0.01, -0.1, -0.5. These are the numbers that I'll use. Now some people also prefer to get closer to 0, like 0.001 or 0.001 and so on. That's okay too. Some people would say that this isn't close enough to discern that the limit was 4. Sure, I would agree with that. And if you picked 1.999 or 1.9999 or 2.0001, you would see that they do get closer and closer and closer to 4, a -4 for that problem. So, looking at number 6, we'll type this in, parentheses for the numerator, second parentheses for the expression 2 plus, we have to use x, cubed to the third, minus 8. Close off that parentheses for the numerator. We divide by, we don't need a parentheses because it's just the variable, h. All right, so now we go to our table. So delete all these. -0.5, -0.1, -0.01, 0.01, 0.1, 0.5. All right. So looking at this, we have 9.25, 11.41, 11.94, 12.06, 12.61, and 15.25. So looking at this, as we approach 0, it seems that we are getting closer and closer to 12. So the limit as h approaches 0 of this expression, 2 plus h cubed minus 8 over h equals 12. That's what our limit appears to be. Now on to the last page. Now here, our limit has x approaching 0, but only from the positive side. So that means that now some people are very clear about the numbers have to follow the way the number line is oriented. So some would say that since we're approaching 0 from the positive side, our numbers have to follow this direction and go down. But some people prefer to have their numbers read from left to right. So this problem causes some difficulty with some people because of different preferences. Now what I'm going to do is I'm going to put our goal over here. I'm going to put 0 there and say that we have to approach 0, but it has to be from the positive side. Now for some people this may be confusing and you may want to put 0 over here to follow the number line, and that's okay. There's nothing wrong with that. So let's see. Let's start with 0.1. Now we're going to get really close to 0. So 0.01. 0.001. Now I could keep writing this, but I don't want to keep writing zeros. Now if you think about it, this is 10 to the negative first, 10 to the negative second, 10 to the negative third. I could just write 10 to the negative fourth, 10 to the negative fifth, 10 to the negative sixth, which was much similar to a problem we had before where we were approaching infinity. We can do the same thing here. All right. So now on our calculator, we can enter in this expression, 1 plus x, close off the expression, raise it to, parentheses for the exponent, 1 over x. Go to our table. We'll delete out what's there. 0.1, 0.01, 0.001, and then 10 to the negative fourth, 10 to the negative fifth, 10 to the negative sixth. And looking here, we can see that at the last two, those decimals, they don't change. So writing this down, we're going to have 2.59, 2.70, 2.7169, 2.7181, 2.7183, 2.7183. So that decimal seems to lock in pretty closely at 2.7183. So x approaches 0 from the positive side of 1 plus x to the 1 over x. Now it's equal to this decimal. Now some people may recognize this as 2.7183. This decimal actually doesn't end because this is equal to the transcendental number e. That's what this limit is. This limit is how we derive the value for e, the value for all our natural logarithms. All right, so now for our last one. Here we're approaching negative infinity. Now I'm going to put negative infinity over here at this end of our chart. So we want our numbers to get closer and closer to negative infinity. So we'll say negative 10, negative 10 cubed, negative 10 to the sixth, negative 10 to the ninth, negative 10 to the 12th, negative 10 to the 15th. So let's enter in this into our calculator. We have parentheses for the numerator, 4x squared minus 3, close parentheses for the numerator, divided by parentheses for the denominator, 3x plus 2, and close that parentheses for the denominator. So I go to my table, and I delete out what's there. So negative 10 cubed, negative 10 to the sixth, negative 10 to the ninth, negative 10 to the 12th, negative 10 to the 15th. So we have negative 14.18, and then we have negative 1334, and then we have negative 1.3 times 10 to the 6th, negative 1.3 times 10 to the 9th, and then negative 1 times 10 to the 12th, and negative 1 times 10 to the 15th. Looking at this, the numbers actually don't get close to anything. They just keep getting more and more negative. And so, since it's not getting close to anything, we could say that the limit does not exist. That's how some people would answer it. But there are other teachers and other calculus books that say, well, it's going down, down, down forever. So what's it getting closer to? Well, that's what negative infinity is. So some people would say that actually the limit does exist. The limit as x approaches negative infinity of 4x squared minus 3 over 3x plus 2 equals negative infinity. Some teachers will pose it this way, some teachers will pose it this way. I'm not going to say who I think is right or wrong. I'm just helping to prepare you either way. So, hope this helped. If you liked the video, please give a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.